right. Well, good morning, everybody. I'm Jessica Nadd, and I'm the Executive Director for Great Plains Regeneration. You can find our booth right up here at the corner. Gail Fuller is actually running the booth for me. He's one of our board members. We also have Steve DeWitt running around here somewhere. He is another board member of Great Plains Regeneration. Liz Haney, Jimmy Emmons, and a couple other folks here serve as advisors on our committee. So go ahead and check out what we're up to. We are a nonprofit that is focused on the enhancement of soil health for healthy planet, healthy people, and healthy animals. The way in which we activate our mission is really threefold. The first is what we see here today: farmer-led education, rancher-led education, and that's why I'm so passionate about the Soil Health Workshop today. The second way that we activate our mission is through watershed regeneration. We work with Kansas Alliance for Wetlands and Streams. As one of the best indicators of our soil health practices at the field level is really through water quality. And then the third way is through new market development, and we really covered a lot of that new market development yesterday. But if you have further questions, come over and see Gail Fuller. You can see Soil Regen with some of the work they're doing, and a couple other of our vendors here. We've also got Midland Genetics, Kaufman Seeds representing today. Go check out the Soil Health Alliance back there in the corner. We have Heartland Soil Samples, PrairieFood booth, Pheasants Forever, Quail Forever, Green Cover Seed, and then yesterday we had Greenfield Robotics actually brought some demonstrations of some equipment that they're using out in the field to mechanically work and terminate different weed pressures that we have. And then Wise Up Food and Better Fed Foods were some of our sponsors for the last 2 days. So guess what's going on today? First of all, yesterday, we had over 250 people participate in the ribbon cutting and the PrairieFood Forum, and we represented 13 states. So I just think that is phenomenal. You know, we put these types of events on. We put ourselves out there as folks that are trying to be a liaison for education, and it's so amazing when we see things come to fruition. So speaking of that, I'd like to introduce to you the folks that are going to be leading the workshop today, two of my very good friends. I have Dr. Liz Haney with Soil Regen, and I have Dr. Trish Jackson. So I'm going to tell you a little bit about them, who they are, and then I'm going to hand it over to them for the rest of the day. So, okay, so Soil Regen, the booth over here, Soil Regen is the conviction that the foundation of agriculture starts from the ground up with soil-plant interactions. By partnering with nature and utilizing holistic management practices, we can improve farmer-rancher profitability, human health, resilience to climate, carbon storage, and water quality and quantity. So for more information, go check out Soil Regen. And as the introduction to PrairieFood, which you've probably gotten a hefty dose of that introduction, so PrairieFood is the micro-carbon-rich soil amendment produced by readily available biomass waste sources. They're restoring the carbon that feeds the soil. PrairieFood has the potential to revolutionize the way the world farms and bring sustainability to agriculture that has never been seen before. So on that note, I would like to introduce to you Dr. Liz Haney and Dr. Trish Jackson.
Do you need help getting down?
I think I'll be okay.
Okay. I'm a little bit taller than Jess, so I'm going to take the mic. I wanted to just give a brief introduction to who I am. I'm Liz Haney. I hate to admit it, I'm a soil scientist. Oh, stop. But I started Soil Regen back in 2019 as a way to educate and bring people together. I took a brief hiatus going into basically the industrial ag system, and came around this summer after COVID and started getting around people again and meeting all my soil health community and all my friends and being around Trish. Decided I couldn't do that anymore. And so I jumped off a cliff and went out into the world, and now we're revamping Soil Regen with our partners, Russell Hedrick and Sarah Varble. Sarah's not here right now, but Russell's around here somewhere. So we got introduced to PrairieFood through Lance Gunderson and are so excited to be partnering with them. We share the same visions the 3P, the people, the planet, and profitability, that's where we stand as well. We want you to be profitable. We want to save the world for our kids, and we want everybody to be happy and learn from the soil health community. So we're very excited to be here. Thanks.
Yeah.
You ready?
Yeah. Well, good morning. Here I am again. So if you were here first thing in the morning yesterday, will you raise your hand if you heard me tomorrow or yesterday? Tomorrow. Wow, a lot of you. Okay. So I'm just coming out of a career in higher education not that long ago before I joined the PrairieFood team. And I taught an 8 o'clock class that was a required credit for graduation. And so hopefully I will be lively enough for you because I have experience being that first person that you hear in the morning. There's going to be a little bit of a review about what I talked about yesterday, but I'm going to add to it. Okay, so that's what every good professor does, right? And so this is the same slide I started with yesterday. With and without PrairieFood, Mike Chagrew's aha moment. So he's the man behind this photograph. And so we were getting some questions yesterday about PrairieFood. So I wanted to clarify exactly what it is. We're taking spent distiller's grain, actually from Pratt Energy right around the corner, and manure from a feed yard, and we're putting it through a process that shreds all those materials into basically tiny little carbon molecules. So PrairieFood is not a biologic. We like to say that we're bug agnostic. We will feed everything, everywhere. Your soil has plenty of biology in it. Sometimes it needs to bounce back because it's been abused for a while. And so when you get that food source in the soil, all of a sudden that starts happening. And some people realize, if they know a little bit more about biology, that really disturbed systems are a lot more bacteria dominated. And so what we've seen in our test results when we look at the biology is that we start to build fungal populations. And so we're seeing essentially evidence that the soil ecosystem is starting to heal itself when you feed that biology. Okay, so PrairieFood is not a biologic, it is food for the biology, okay? Okay, so like Liz mentioned, we are a 3P bottom line company. We're all about people, planet, and profit. And so I wanted to put that into a little bit of a mission statement for today. We want to help farmers be successful through transforming agriculture into a people-first, planet-healing, and profit-healthy endeavor. And so you can feel good about this and make a better bottom line, a healthier bottom line at the same time. And to do that, you have to really pay attention to the soil. So it's a good thing we have people like Liz Haney around to ask questions about that soil. Oh, there we go. Oh, I had that. Okay. Here's another slide from yesterday just to bring that mission home. We're really asking farmers to think about the world a little bit differently than maybe they have traditionally. A lot of you that are already here are on board already, so I'm not going to spend a lot of time here, but in the world of agriculture, I just want to emphasize, I feel like we're undergoing this paradigm shift. So from the paradigm of this reductionistic, disturbing Mother Nature, fighting Mother Nature sense, into a new world where we're partnering with Mother Nature, healing the soil, taking a systems approach. And that's something that we'll hear about from Russell today, how to take that systems approach. So let's talk about what is soil health. Does anybody have an idea how to define that? It's not that easy. Does anybody want to volunteer and answer? Sure.
Soil that is functioning the way it was originally created throughout history and before we screwed it up.
Soil that is functioning as it was meant to be before people screwed it up. That's a good one. Does anybody want to add to that? Well, it's one of those things, you know it when you see it. It's hard to define, right? It's complicated, but you know it when you see it. So you can look at this picture here of Brazilian soil, and you know the side on the left is not so good. It's, you know, iron oxides and aluminum oxides, basically. Not a whole lot going on in that soil, not a lot of fertility. And on the right side, where we have that Amazonian dark earth, or terra preta, you know that's full of carbon, you know that it's full of life. If you get out in the field, you can smell that smell, you know it when you see it. And you can also look at the plants, right, and see how they're doing. So another little bit of a review point here, that soil health is intimately linked to human health. When I was in graduate school at KU, one of the most poignant examples of this was a paper that I read that had been done in the Detroit area. So they looked at the soils next to highways in Detroit, okay? And they were looking at lead levels in the soils. And the farther you got away from the highway, you know, the lower those lead levels went. So where was that lead coming from? Gas, right, leaded gasoline. But the most important point here is that when they looked at the blood lead levels of the people, they were directly correlated with the blood or the lead levels in the soil. And that's how intimately we are connected to the soil, just one example of that. We also would like to be feeding ourselves and our children good food and not exposing ourselves to harmful chemicals. So we really need to take care of that soil health because it's going to help us be healthy as well. So let's talk a little bit about measuring soil health. We're going to get a lot more information from Lance Gunderson today on this. And I touched on it yesterday that in the past, we have really focused on the physical and the chemical aspects of soil. So if you send your soil samples off to a traditional soil lab, you'll get something like a Malick soil test or something like that, and that uses really harsh chemicals to extract all the stuff that's in that soil. So you're getting some information, but is it useful? Yes and no. Why would it maybe not be that useful? Does anybody have an idea? It's not that accurate. Why? Yeah. Yeah. So she's saying it was removed from its environment. It's just a moment in time. It's
So chemical and so physical, but it doesn't necessarily tell you about the biology.
It doesn't tell you about the biology. So that's exactly right. It tells you something about that chemistry in the soil. What else? There's one more thing that we're missing here. Does a plant have access to those harsh chemicals in nature? No. And so why would we be measuring or, trusting that number that the plant has access to that when the plant does not have the chemicals to extract those chemicals from the soil? And so that's why Rick Haney and Liz Haney developed the Haney Soil Health Test. It not only measures the biology, which is this aspect of soil we've been missing all along, but it also uses extractants that are found in nature, like water, and an organic acid that mimics a plant root exudate. And so we need to also think about how we're measuring soil health so that we really get a true picture of how that soil is functioning, and we can improve from there. And so here's the 5 core principles of regenerative ag. I'm going to come back. You guys, what are they? Keep your soil covered. Living roots. Minimal disturbance. Biodiversity. Integrated livestock. Awesome. A for the day. Good job. And so if we can do those things, and Jimmy Emmons was saying, you got to be all in here, but my message is start somewhere, just do something to get started, and then work towards all of those principles. We want to build resiliency in our soils so that we can have economic resiliency, and that filters through into rural communities. Okay, so I want to talk specifically about PrairieFood now. Why farmers love PrairieFood, and I have a flyer that summarizes this if you want to take this home instead of having to take notes. So why farmers love PrairieFood, reason number 1. We're building soil organic matter. Why do we care about that? Everybody knows if you have higher SOM, your soil's healthier. Isn't that kind of an assumption that we make? Why else do we care? That's a huge one, right? It increases your water holding capacity. Carbon is a sponge for water. And so a big portion of what's in soil organic matter is carbon. It's not 100% carbon, but it's a big portion. And so what PrairieFood does is it feeds the soil biology so that plant-soil interaction is healed. Remember this from yesterday? The plant can function better and grow more, and then it's photosynthesizing more and flushing carbon down into the soil. So when we repair that connection, we can build soil organic matter. So when we see increases in soil organic matter in our PrairieFood trials, it's not because we're putting all that carbon down with PrairieFood, okay? The carbon we put down with PrairieFood starts that process. It gets things started. It's a catalyst for life. We're feeding the biology that's the basis, the foundation of it all. So I'm going to summarize that here in just a second. Oh, by the way, this picture in the top right is a green cover seed. So they're still here. That's good. So please go visit their booth. They have this awesome booklet there that has all kinds of articles about soil health, different aspects and things that you can do. So that's a really good take home. But they've been research partners with us and we appreciate that. Thank you. The bottom picture here is that soil that I mentioned yesterday that increased 2.5% or soil organic matter in one year from March to March. It's hard to believe. It really happened. We've measured that field more than any other field just so that we could be convinced that it was real. There's something special there. This is in the Platte River Valley, and it has a high pH. It has some unique soils. It's a pretty complex field, so we're trying to understand that. But I don't know if you can see very well. The aggregation on this soil is off the charts. So soil aggregation is, when you get that perfect crumble, you get some of those PEDs, they're called, some little particles just sticking together, and it's just perfect. It has that smell, that smell, is this wonderful earthy smell. And so that is one thing that you can monitor on your own, just observationally, to see how your soil's doing. Get a spade out, look at it, smell it, touch it, maybe taste it if you like that sort of thing. But we've seen this change. When we first went out in that field, we couldn't even get a probe in it. And not that many, weeks, maybe a couple of months later, when we went back out to resample, it happened so fast, this transformation. And it was, all we did was put PrairieFood on and a cover crop. And so the PrairieFood got the biology started, the cover crop continued to feed that biology. And so that partnership between using PrairieFood to ramp up that system and then using these regenerative ag techniques is a powerful tool set. Carbon builds soil health. So all those 5 principles are here to make these wheels turn, to make the machine work for you. So keeping that carbon, if you limit the disturbance, you're not evolving carbon out into the atmosphere. So when you turn over soil, that organic matter that's in the soil connects with oxygen. It reacts with the oxygen in the atmosphere, and guess what? Then it turns into carbon dioxide. So you're losing organic matter just because it's being exposed to the air, as simple as that. We can build diversity in the living roots, and that actually adds carbon, okay? We're going to hear about that soil biology and that power of biology. And then integrating livestock can also add carbon to your system. Okay, so here's the system. if you weren't clear on how PrairieFood works, this is the summary. We feed the soil microbes. It's just carbon. There's a little bit of some micronutrients that were in that bovine manure. There's a little bit of NPK, some other things. But the main ingredient is carbon, okay? We're feeding the soil microbes. We don't feed plants, okay? But the microbes then, when you feed them, they grow, they reproduce, and then that microbial army transforms nutrients for plant uptake. That's that free service that we really need. I just talked with someone this morning who said, I have, soil that has everything I need in it, but the plants aren't growing. The plants aren't thriving. And he did a Haney test, and he said the missing ingredient was the biology. If the biology is not there, it can't transform those nutrients into plant-available forms, and so your system's not working right. So once we get that fired up, the plants photosynthesize more and get bigger. We've seen a 33% increase in biomass above and below the ground when plants are grown with PrairieFood compared to a control plot. So healthy plants flush soil with more liquid carbon. So that's free. That's free carbon. We're pulling it out of the atmosphere. It solves some problems for us and gets it into the soil where it can work for us. And so that symbiosis between the plant and the soil is repaired, that virtuous cycle. Get more soil carbon, plant resilience. When you have that resilience in your soil and the plants are healthier, they can fight off things like diseases and insects. And so that reduces input costs. More biomass. Okay, so this is really all about the soil organic matter. When you have more of that, you get more storage for water. So reason number 2 why farmers love PrairieFood is water. And so on this field that I was talking about, where we saw the increase in soil organic matter, 2.5%, what happened was this field is prone to flooding. And it's right next to the Pratt River. And so whenever it rained, you just have ponding. And so you'd get bare spots all over the place because, the plants couldn't survive that standing water. Once we got that soil organic matter built up, all of a sudden that soil was able to hold all of that water instead of having it pond on top of it. And that has to do with that, also the aggregation and the additional life, probably more earthworms. And so that water is stored in the soil. And then guess what? Didn't have to irrigate so much. And so carbon is a sponge for water. Oh, yes, and what about reducing erosion? When you don't have runoff and you have greater infiltration rates, you don't have erosion. So we were reducing erosion as well when we build up this system. So I kind of referred to this yesterday. I talked about it a little bit differently. This idea, the right picture here from The Secrets of the Soil. I loved that they did that, Secrets of the Soil. I got to go to the Smithsonian and see it. Did anybody get to see the soil display at the Smithsonian in Washington? While it was there, it was outstanding. But we did get all these materials associated with it that we still get to access. Every 1% of soil organic matter that you increase in your soil increases the water holding capacity. So we have 25,000 extra gallons of available soil water per acre. We did the calculation, I said this yesterday, how much extra can you then store for a rainfall event? Do you remember? How many inches? An extra inch. An extra inch of rainfall you can capture and store in your soil. So as you increase soil organic matter, so looking over here at this chart, see this value per acre? Somebody did put a number on this. We've had a lot of discussions around what is the value of water. It's really hard to put a number on it. It probably varies quite a bit geographically. But this is from the USDA, and they say, as you increase your soil organic matter, look at the value of your water holding capacity. Whoopsie. Right there. What else is on this chart, though? This green is available nitrogen, and this purple is available phosphorus. So in soil organic matter, we don't just have carbon, we have other nutrients as well that help the soil function properly. And so as you're building that, you're building those reserves of nitrogen and phosphorus. So why farmers love prairie food, reason number 3 really has to do with nutrients. When the soil biology is functioning, as it should, all of a sudden you can release more nutrients to the plant as it calls for. So plants can ask for what it needs. So one of our trials, there was a zinc deficiency. So it was a very clear, visible zinc deficiency. As you walked into the prairie food plot, it completely disappeared. And so what we know is happening is that connection between, that communication between the soil and the plant was functioning, so the plant was able to call for zinc, and the soil biology was able to respond and provide what the plant needed. So that's related to this idea of nutrient use efficiency. So if you're using an input, remember carbon is a sponge. It's not just a sponge for water, it's a sponge for other nutrients. Carbon is a facilitator of the nitrogen cycle. And so when you do put nitrogen down, and it becomes less mobile if you have a richer in carbon soil pool or carbon pool there. And so you're able to hold on to that for when the plant needs it. And then it's available for the yield that you need to build that yield. And that's how you measure nutrient use efficiency. It's if you put down pound for pound how much nutrient that you put down, how much yield do you get out of that? So you want that number to be higher so you can get a good nutrient use efficiency. So we had some trials this year. I'm not going to go into depth on this, but we had some trials this year that did look at different nutrient levels with different prairie food levels. And so if you want to hear more about that, please visit our booth and do that. We really need to have this conversation because that is last week's chart from DTN on nutrients. So that red line is the cost of nitrogen fertilizer this year. The other line, so the purple line is 2019, and the green line is 2020, and the little dotted gray line is a 5-year average. So you can see kind of over time, it's been pretty stable, and now it's off the chart practically. So this is the time to think about making a change. If you ask a soil health expert, the recommendation is if you start using regenerative practices, you can immediately start backing off on nitrogen. If you do a Haney soil health test, you can get a reasonable, sorry, I forgot to mute my phone. Oh no, something must be happening. But you can get this, a recommendation that's based on all the nitrogen in the soil. So that was referred to yesterday as well. You'll learn more about that today. And so I think I'm going to end with this slide. We had the same rate of nitrogen on these 2 corn areas. And you can clearly see in the prairie food plot that we had repaired, or started to repair at least, that interaction between the plant and the soil. When you do a root dig, it's just really, really obvious what's going on with prairie food. And if you can't explain it, you can really see it in the plant health, in the root vigor. And so I would really encourage you, if you want to get started, prairie food's an easy way to do it, to get started now. I kind of went over time, I just realized, but I wanted to encourage everybody to take a quick 5-minute break so we can set up for the next panel. Unless you have a question, any burning questions out there? I'll be around, okay? So come ask me if you have any questions. And thank you again, everyone, for coming today. 5-minute break. Thanks.